Okay, so like I said, we're going to fill out this chart right here. And if you take any notes, make sure that it's this chart. And so when we are talking about, we're going to be learning about something called end behavior. And the end behavior is really exactly what it sounds like. We're going to be describing the behavior of the ends of our graphs. And so when we have a polynomial that has an even degree, so degrees here, if it has an even degree and a positive leading coefficient. So for an example, if we do y equals 2x squared, so it has an even degree, degree is the tiny number, and a positive leading coefficient, the graph would look kind of something like this. Not exactly, but I can draw a rough sketch of what it would look like. It looks something like this. All right. And so again, my leading coefficient in this example, my LC, is going to be 2, the number in front of the letter, and the degree is going to be 2 as well, which it would be this 2 right here. Okay, and I'm going to have something like that. So when this is true for every time I have an equation that has an even degree and a positive leading coefficient, the graph will look something like this with both ends sticking up like that, okay? When we have that, we describe the end behavior exactly like this. This is going to be what the end behavior is. And so we write the end behavior in the same notation every time. I'm going to be picky of your notation. So we're going to write as, let's do it in blue, the end behavior. So as x approaches, this arrow means approaches, infinity, which I'll show you what that means in 1 second, f of x approaches positive infinity. So let me explain what that means really quick. This graph, the x numbers, let me get pink involved. The x numbers are going horizontal, the y numbers are going vertical. This means as my x numbers go to the infinity direction, positive infinity direction is going to be all the way over here, right? Positive infinity is forever to the right, okay? And so that means as this graph goes forever to the right, forever this direction, f of x, which is my graph that I drew, which is my red graph, goes forever in the up direction. This graph goes forever up to positive infinity. Okay, so this graph goes forever up and to the right. This graph is going forever up and to the right. If I were to keep drawing this graph, it would go forever up and to the right. So this means as x approaches infinity, so as you look to the right of my graph, f of x is also going to the right. It's going up, but it's also going to the right towards infinity. These graphs never end. So as x approaches infinity, f of x approaches infinity. And then for the second half of end behavior, we do the left-hand side. So as x approaches negative infinity, f of x approaches positive infinity. So let me explain what that means. This means as x approaches negative infinity, well, remember, pretend there's numbers on this line. This would be -1, this would be -2, this would be -3. It goes on forever to this line can go on forever towards negative infinity. So this is saying as x approaches negative infinity, which is all the way down this way, what's happening on this side of my graph? Well, that's just saying what's happening on the left side of my graph. My left side of my graph is also going up towards infinity. So it's going all the way up towards infinity, forever going up towards infinity. Okay, so